So today I wanted to go over domain and range in regards to equations, graphing, when you have sets. This is usually difficult for people. People usually struggle most with the domain part. We don't focus too much on range, but the struggle is usually on how to write it. And so I'm hoping that you can get some clarification as I go through this. So the domain of a function is the set of all input values. So that is the values you can put into an equation would be considered the domain. For an equation, we look at all possible input values. So what are all of the values you could possibly plug into an equation? We can't list every single possible number that you can put in an equation, so we usually write it in interval notation, like we do inequalities when you solve them, because it's just impossible to put all of those numbers. You can't write them down. If you have a set of ordered pairs, usually you actually can write down all of the x values of the ordered pairs, which are the inputs. So just looking at an equation, the domain is the inputs or the x. So if you have ordered pairs, you can list all of those x values, and that will give you your domain, because there's a specific number, like if you have 5 ordered pairs, 5 numbers to list is not bad. When we're looking at a graph, usually a graph also has like an infinite number of inputs, because you can zoom out of your graph. It doesn't stop. If you graph something with Desmos, you can zoom out, zoom out, zoom out. The graph will just go on forever. So when we look at graphing, we often have to also use interval notation. And when we look at a graph and we're trying to find the domain, we don't focus on just what we see. We have to consider the parts that we don't see as well. So range is the output values. So if you're looking at ordered pairs, that would be the y values. So you plug in some number for x, what you get out is the y. And so just like equations, there's an infinite number of outputs essentially. And what those possible outputs are based on the inputs. So while you may theoretically be able to plug in any number you want for x, the equation dictates what comes out, so you may not get every single possible number out. There may be some numbers you just can't get out depending on how you solve it. An example of this is if you have a fraction and you have an x in the denominator, you can't, there's certain numbers you can't plug in, and there are certain things you can't get out. You can't plug in 0 in a denominator, because that would be dividing by 0. And let's say you don't have a variable on the top, the only way to get 0 out is if you had a variable on the top, and so you can't get 0 out. So there's certain things you can't put in, certain things you can't put out, so you have to think about what is possible. And then for graphs, just like with domain, you have to essentially zoom out or think about the parts of the graph that you don't see and kind of think about, well, what is the pattern here? Where does it continue? What is the trend? So you have to do a lot of thinking and noticing the pattern when it comes to equations and graphs, so that you have an idea of the domain and range. So I've already sort of mentioned this, but when we're writing domain and range, if there's a discrete set of values, and discrete just means that you have like a specific number of values. It's not like you have infinite possible numbers, but there's an actual number associated with it. Then you would list them in roster form. And a roster form is where you just put it in a set. So you would just list the numbers in set notation with the curly braces. So if you had an ordered pair and there was like 5 input numbers, you would list all 5 numbers in a single set, and if there was 5 outputs, you would list all the outputs in a set. So that's roster form, where you're specifically listing all of the values. If you have an equation, we have to use interval notation, where you're indicating whether something goes to infinity or maybe it's in between two numbers. So that's where you have to use parentheses and the brackets and all that we looked at when we were learning about linear inequalities. And for graphs, we may use a combination of both depending on what the graph looks like, because you may have a graph where there's a long section where you have an infinite number of possibilities, and then you may have some specific points. And so you may have to use both of them depending on what the graph looks like. So knowing what you're looking at and helps you determine how you write your answer for your domain and range. So I've got an example here where we could have domain and range and things that are not mathy. So this is an example. We just have 5 students with their final grades. So Lorcan got an A, Anne has a D, Martina has an A, Antoine got a C, and then Michaela got a B. So this is just 5, right? I picked these from a random name generator, actually. Those exist. And we're going to find the domain range. So the domain is the input and the range is the output. And generally, it's like the input is, we're looking at a specific relationship. So in this case, our domain is going to be the name of the student, because if you give me the name of the student, I can tell you what grade they got. If we looked at it the other way and said, oh, you give me a grade, there are multiple grades here that belong to like the same letter A. There are multiple students that got an A, so I can't tell you what student it belongs to. So when you're trying to decide domain and range and it's not specified like X and Y, like ordered pairs, you look at what is the relationship, what has an input-output relationship. And so in this case, our domain is going to be the names, and then the range is going to be the grades. So I'm going to write that down. So our domain, I don't want that in red. Is going to be the name of the student, and then the range is going to be the grade, because that's where we have a relationship that we can actually look at. You can figure something out based off of the inputs and the outputs. So because we don't have like a graph, we don't have an equation, we just have a list of things, this is where we use roster notation. And you just list everything, and actually I'm not going to have enough room if I put that there. So I have to use a curly brace, and this is required if you're going to enter it into Alex. That curly brace is telling us we have a set, and all of our inputs are the names. So you're just going to list the name of each student separated by commas, and this is roster notation. So that's the domain. The range would be the outputs that are associated with that. So that would be listing the possible grades. And if it shows up more than once, you need to list it more than once. You just list it, you know, you don't have to, like the letter A, I don't have to list that twice. I can just list it once. And it doesn't have to be in any order here. So I'm just listing all of the possible grades that we have here, A, B, C, and D. And I just did it in the order that I saw them going down the list, but you could put it in alphabetical order if you wanted. There's no particular order here. We're just listing what are the inputs and what are the outputs. So even though we have 5 inputs, we actually have 4 outputs, but that's okay, because it's just all the possible or the associated outputs. So I should make a note that we used roster notation here, where you're specifically listing your X's or inputs, and then you're listing your outputs. Are there any questions so far? Okay. Moving on. Most of the time what we're going to be dealing with are graphs. graphs or equations. So I just wanted to do one example, the roster notation, but most of the time is graphs. So just to zoom in, I try to draw this by hand, so it's not the best curve. But we have a graph, so it starts here at -1, 1, where A is, and then it goes through 0, 3 at B, and then it curves back down. Its lowest point here is at 2, -3, and then it stops at D here at 5, 2, but it's an open circle at D, which means that that point is not included. So the open circle means that point is not part of the graph, but we need to have an ending point. So we just put a circle, but it's open. A closed circle, that point is part of the graph. So this is the graph we're looking at. And to find the domain and range of a graph, the domain is the input values. So that would be the x values, and then the range is the output, the y values. So what I usually do is I look at this as a number line and then I highlight things. So first, we're finding the domain and the range. And because this is a graph and it's a continuous line, we have to use interval notation. We're not going to list every single possible number because there's an infinite number. Anywhere that I have an x value that's on the graph that has a piece of the graph, then that's part of my answer. And there's just too many to list. So what I do is I highlight. So I take the leftmost part on my graph where I have an x value, and then I just highlight everything in the number line where I have parts of my graph. So the most left part of the graph is at -1 where it starts, and then it ends at 5. So I didn't do a very good job at ending at 5. Let me try this again. That looks much better. There we go. So it starts at -1 and it ends at 5. So think of this as our number line when we're doing linear inequalities. So I've got -1 and 5 on the graph, and I'm shading basically in between those. That's where our domain is. That's where we have the graph, where it exists. Now on the left, if you have a closed circle, that means it's included, so that always goes with a bracket. So I'd have a bracket right there. And then an open circle means not included, so that's a parenthesis. So the parenthesis is going to face to the left. So our domain is in interval notation, -1 to 5. So this graph is between the x values of -1 and 5. And we have points for all of those except for 5. 5 is not included. So I go back and I look at my number line and draw it, and then draw out my interval notation. So the domain I'm going to do similarly, and I'm going to do that in a different color. So the the range I'm going to do similarly. And so the range is y. So I'm going to, again, use a highlighter, and I'm looking at the y values. Where do I have things on my graph that's like y? And I'm going to look at the number line here, the y-axis. So my highest point is at B at 3, and then the lowest point is at -3 here. So I'm doing my best to kind of highlight. So my graph has y values in between -3 and 3. So that part that I've highlighted is in between there. That's where a graph is kind of hanging out. Like if you think about it, our graph doesn't go beyond these maximum and minimum lines. That's where it's present. So that's where it stays in between. It stays in between those values. So once I draw that, I'm again going to go to a number line, but I'm going to look at it as far as y goes. And this bottommost number is the left number. And then here we've got the right number. You have to kind of think about it. If you took your number line and you rotated it, like you turned it clockwise, if you're doing this on paper, you can literally turn your paper to look at this. And so our graph for y is between -3 and 3. So I'm going to shade that in. Make sure it's very obvious here. Now, at our lowest point, I have a closed circle, so that means that's included, so that's a bracket. And then at the highest point, it's a closed circle, so that means it's included, so that is also a bracket. So here, I'm including the endpoints, and I have a bracket on either end. And this puts my range at -3 to 3. So this is just telling us that this graph has x values between -1 and 5, not including 5, and it has y values between -3 and 3. So it's telling you where is this graph present in, our graphing system, basically. It's sort of, you can think of it almost as telling you what you would put the window of your graph in. If you were using a graphing calculator, where would you want to center it? And so knowing the domain and range can help you figure out where you want to center your graph. Are there any questions? Okay. So moving on, I have a different example here. So this one, we have a very clear closed dot on one end, but we don't have a dot on the other end. So if there is no dot where it ends, you assume it's an arrow, and the arrow means that it goes on forever. So that arrow means that this line is just going to continue and continue on forever. Even though I don't see it as part of the graph, it's still going to continue following that pattern. That was not a great, but let's see, it just follows that pattern. It's just going to continue on and on and on forever. So that arrow is telling us that if we kept zooming out, zooming out, zooming out, it's just going to keep going down, down, down there. So if you don't see a dot, assume it's an arrow and it goes on forever. So you can just kind of draw that in just to help you visualize. So we're going to start with the domain, which is our x values. And so I'm going to go back to my highlighter. And so I'm going to just look, okay, you want to kind of say, okay, I don't have anything to the left of that yellow line. So my domain is starting. I'm going to have to approximate that. I'm going to say that's about at -1. We usually try to put these at whole numbers when they're graphs, especially if you can't tell here. So we're going to say that's -1. And then this goes on forever. And then because it's slanted and that arrow is going to tell us that we're just going to keep going to the right because it's slanted. It's not going straight down. It's slightly slanted. So it's just going to keep continuing slanting out. So if there's no closed dot, just assume it goes on forever, and that holds for the x and the y. So if I'm putting this on a number line, so I've got my number line. My left number, we said was -1 based off of what we can see. And I'm going to just label -infinity and positive infinity on my number line. So we're saying that our graph is shading, so we have everything to the right, and then because of the arrow, it just goes on forever. So that's what we're shading on our number line. And because we have a closed circle or closed dot at -1, then that's going to be a bracket. So that is my graph, and so then that tells me I'm going from -1 on the left, the bracket, to infinity on the right, and that always has a parenthesis. So you can think of that little arrow sort of like a parenthesis. It's curved if you're trying to remember what your symbols are. And if you're wondering, how did I know that was -1? I mentioned that I estimated. Well, because the dashes are listed at every 2, I knew that this dash had to be at -2. So I said, okay, about halfway, then it must be at -1. So you have to kind of look at what are my dashes counting by so that you know what your values are. So that is domain. So now let's do the range, which are going to be the y values. So again, I'm going to take my highlighter and I'm going to say, okay, where's my y values? Where are they going? So like the highest point, okay, that was very bad. I was trying to draw a straight line basically. Highest point is roughly up here. And so I want to start shading my graph. And then the lowest point, it has an arrow, so it goes down forever. So it's just going to keep going down forever. So I'm going to draw my number line, put a negative infinity to positive infinity, and we're looking at the y for the range. So my lowest point is negative infinity because my arrow is going down. So that's where I'm going to be shading. So my shading is going to be on the left, but I need to know where to stop on the right because it doesn't go up forever. There's a clear stopping point on the right. And I need to figure out where is that stopping. So we're going to have to estimate again. So it looks like if I try to go straight, it's not exactly halfway between 6 and 7, but I'm going to say it's close enough for our purposes. So let's say 7 is the highest point that it goes to. So we're going to put 7 here on the number line. And then we're including 7 because it is solid at that highest point. And then it goes down to the negative number. So it goes to the left as far as your number line, or if you're looking on the actual graph, it's going down towards the negatives. So that gives you your picture, and then from there you can write your interval notation. So we always read it left to right. So at left is negative infinity, and infinity always has a parenthesis. And then at the right, we stopped at 7, which has a bracket. So that makes our range negative infinity to 7. And these are both written in interval notation. And it's easier to write an interval notation than trying to write every single possible number that you could have there, because you can't. Are there any questions? Okay, so here's another graph. And so this one, I'm going to zoom in on it. So you can see that not every box is labeled, so you have to figure out what these labels are. So I've got 1, 2, 3, 4, 5. It's 5 tick marks to hit 5, so that means we're counting by ones. So you just have to keep that in mind if you have something that's not labeled. So this is a piecewise function, which means we have separate pieces. And when you have something that's separate pieces, you have to write an interval notation for each section. So I have to, like the left one that's below the x-axis, I have to write something for there. Then I have to write part for the curved part, and then I have to write something for the little dot. So we're going to have 3 separate sections here that we're writing for because we have 3 separate sections of the graph. So the process is the same, it's just going to look a little different because we've got different sections. So if it helps, you could label your ordered pairs. So like the dot here is at 5, 5. We have an open circle at 2, 4, another open circle at 0, 0, and closed circle at 0, -1, and then we've got 1, 2, -3, -4. So if it helps to label the endpoints, that is a good thing to do, just so you know what numbers you're looking at. So I'm going to start with the domain, and I'm going to do the highlighter method again. So it's a little easier when you have like a clear grid here. So that first section is on that part that I've highlighted on the graph. So it goes from -3 to 0. Then we have a second section that stops at 2. And so you can see those two sections when you're looking at the x values actually joined together. And then you just have a dot here at 5. So because the first two sections join together, we're going to actually combine that in one, and then we're going to have a little dot. So when I draw this on a number line, so my left part that I have, 1, 2, that's at -3, and then I have it highlighted all the way until I hit 2, and then I have a dot at 5. So a dot, I'm going to just put a little circle there, and then I'm highlighted between -3 and 2. So now I have to look at what the circles are. So at an x value of -3, so if I follow down, that is a closed circle. So that's going to be a bracket. And then at our other endpoint, if I follow up, that's an open circle, so that's going to be a parenthesis. So I have two sections here. I have a section from -3 to 2, and then a dot at 5. So when we write this, this is one of those situations where I said you may combine your interval notation with a roster notation. So we read it from left to right. So I have -3 to 2. And then when I have to combine it with something, that's where we use that union symbol that we learned about. The union is how we combine these pieces. And then when you just have a single dot, you use the roster notation and you just list the x value. So we have interval notation and roster notation because we have different sections of the graph here. We have a part that's continuous, and then we have a single dot. So I'm going to erase these so I can do the range. Oops, I erased too much. Oh well. I can't only erase the yellow. So let's look at the range, which is the y values here. So again, I'm going to get a highlighter, I'm going to do green. And so let's see, I've got my highest point there at 5, which is a dot. And then I have parts, this section right here, where I have part of the graph. And then I start again here, and then I go down to here. So here now we have 3 separate sections that don't connect. So we're going to have 3 pieces when we write our range. So we have 3 sections here. So again, I'm going to write my number line. So my lowest point is a y value of -4. So I'm just reading that off of that lowest point. And the domain, the range is the y. So that's at -4. And then it stops here at a y value of -1. And those have closed circles there, so those are going to be, so I'm going to graph this and then put brackets at either side because they're closed circles. Then I have a gap, and then I hit it again at 0, and that has an open circle. So that's going to be parenthesis. And then it stops. Actually, it's probably easier if I go on the right there. It stops at a y value of 4. And that also has an open circle, so that's going to be parentheses. And then I shade in between those. And then at 5, we just have a single dot and it's closed. So I'm going to just draw that dot. So I've got 3 separate pieces here of my graph that I'm putting together. So when I write the range, I have my bracket at -4 to -1. And then I need to combine it with a second piece. So I have my union symbol. Then I have my second piece from 0 to 4 with parentheses. And then I have a third piece, which is the y value of 5. And so if it's a single number, we just put it in the curly braces. Now this is more complicated than anything you're going to see, but I think that this is a good one to show you what you do when you have certain pieces like this and how you can see that you can kind of mix and match. Are there any questions? Okay. Oh, this is not working. What this white box is supposed to be a graphing calculator that I embedded into PowerPoint, but it doesn't seem to. Let's try reloading it. It doesn't want to work. Okay, we're gonna have to switch back and forth between Desmos. I thought I was being sneaky and being able to include a graphing calculator into PowerPoint so I wouldn't have to switch between the two, but unfortunately it's not working. So I'm moving on to what to do when you have equations. So when there's an equation, there are 2 ways to find domain and range. The first is to graph it and then use the graphing method that we've just been doing. The second is to memorize sort of what the domain and range look like for certain types of functions or certain types of equations. And that's what we refer to the parent functions, which is something that you're going to learn about this week, is different types of functions, what they look like, what their domain and range is. And if you recognize like this is linear because there's no variables with exponents, then you know, okay, linear equations always have this domain and range. If you look at it and you're like, this is a quadratic, I have an exponent of 2, this is what the domain and range look like. So it's really important to be able to recognize the type of equation for graphing purposes, for domain and range, and for solving purposes, because knowing that tells you what area you should look at for solving. So here, this is what we call linear because there are no exponents. So when you graph this, you actually get the graph of a line, hence the word linear. So since my thing is not showing up here, I'm going to have to open up Desmos. And kind of pull it over here. We'll just pretend that it's in the same area where I put that box. So go on the graphing calculator. So what you're going to do is when you open up Desmos, you just literally type in the exact equation that you see. Y equals -3x plus 5. And then it will give you a graph. Now, the graph doesn't give you any arrows here to show that it goes on forever, but you can zoom out and you'll see it just keeps going on forever and ever. So you can do the same sort of process. So I'm going to just click and drag to move it around. You can do the same sort of process when we're graphing, where you kind of see, okay, what is this looking like? So I'm going to have like arrows here. Now I'm going to attempt, unfortunately I can't, the reason why I did this is because I want to be able to draw on it, but so I'm going to just see if it'll let me. I can't even draw on that box. That's really disappointing. Come on. Let's try this. So our graph, this is not a very good line, but it basically looks like this and it goes on forever. So if I was putting this and so it's going to look like that, and you're making your number line thing, you end up with a number line. It's going to cover the whole number line because it goes on forever on the left and it goes on forever on the right. So there's no spot where it ends. So if it never ends anywhere, then it goes on forever, and that's what we say is all real numbers. So the key here is linear equations, which graph as lines, have the following domain and range, and it's the same for every slanted line. So it goes from negative infinity to positive infinity for both domain and range because they go on forever, both in the x and the y direction. This also means that you can plug in any number you want, you'll always get something out. So there's no number that you're going to plug in and get an error. When you have a linear equation, you can plug in anything as long as it's a slanted line. If it's a vertical line, that's another story. If it's a horizontal line, it's another story. But when it's slanted like this, which is most linear equations, you can plug in any number you want. And so the domain and range is going to be negative infinity to positive infinity, no matter what it looks like. Just that's always what it is. So if you can recognize the form of an equation, seeing that there's an x and a y, so you need to have both an x and a y and have no exponents, then that tells you immediately what the domain and the range is. So that's one of these things that you're going to want to have in your notes, and I think there's actually a print-off this week that you can download where it lists all of these things. But that saves you a lot of time. You don't even have to graph it as long as you recognize the equation. Again, my page is not working here. Try reloading just in case. No. Okay. So we have a different equation here. And because we have an exponent of 2, it keeps moving on me. The exponent of 2 is telling us that this is a quadratic equation. And so quadratic equations have certain rules for the domain and range as well. And you can see those by graphing them. Oops. So I'm going to bring back Desmos. And we have y equals x. And if you want to know how to get the exponent, there's 2 ways you can do it. So on the bottom left, there's this keypad, and you can hit the squared button. Otherwise, on your keyboard, above the number 6, there's a caret symbol that also means exponent. So if you hit Shift 6, that will also get you up into the exponent. And this works the same way in ALEC. So some of you may have already figured out that shortcut. And then I have my -2. So this is what a quadratic equation looks like. The shape is called a parabola. It forms a U. The U is usually going up or it's going down. So as we get later in the class, you'll learn how to know whether it's an up one or a down one, but it always looks like a U. And the thing about this is that the x values go on forever. So if I zoom out, that top part is just going to keep getting taller and taller and taller. So the x values go on forever, but the y values only go forever in one direction. They certainly don't go any more negative than this. So one side of the range is going to go to infinity, but not the other side. The domain is going to go from negative infinity to positive infinity, just like the line. Because you can plug any number you want in for x, you're not going to get any errors. So I've got my sketch here. So it approximately looks something like this, and it's going to go on forever going up. And then if you're looking at left or right, the left and right parts both have arrows, so they're going to go on forever. So the domain is negative infinity to positive infinity. But the range is always, you have to figure out what the low or the high point is, because your range will go from something to positive infinity if it opens up, or if it opens down, this will be reversed. It'll go from negative infinity to stopping point. So we need to figure out what this lowest value is. So I'm going to go back to the graph. Now, what's really nice about Desmos is if I click on the graph, it marks where it hits the axis. And if you highlight it or you hover over it, it tells you the ordered pair. So this is telling us our lowest y value is -2, because -2 is the y value ordered pair. So our range is going to start at -2, and then it goes up forever to infinity. So that's going to be similar for all quadratic equations. The number with the range depends on what the actual point is that it's the lowest, or if it's reversed and it's the highest. But the domain is always going to be negative infinity to positive infinity. So that's something to note whenever you see this shape, because you automatically know what the domain is going to be. Are there any questions so far? Okay. So I've got two more. Again, doesn't want to graph, doesn't want to have the thing. But this is an absolute value equation that we graph, because you've got those vertical lines. So this is absolute value. And again, those also have a certain shape and a certain way that we write the domain and range for every absolute value. So I'm going to head over to Desmos so I can graph this. So I've got y equals, and then if you're wondering how to do absolute values, you might be looking here, you hit the keyboard, there's this button right here. This is the absolute value button. And it doesn't finish it, so you can see that it didn't actually put that ending point. So you would have to end it yourself. I wonder if hitting that, yeah, if you hit the button again, that will actually end it. It's also, and this also works on Alex, it's above the backspace button. So on your keyboard, you've got your backspace, which is usually above the enter button. So hitting shift, you see a vertical line. That's what we use for absolute values. So I'm going to just type inside the absolute values. We've got x plus 3. So you can see here we get a V. So an absolute value graph always gives you a V shape. You can see that's very similar to the quadratic, where it has a lowest point and then it kind of goes up forever in either direction. I can zoom out and it just keeps getting bigger and bigger and bigger, and it never stops as far as the x goes, and on the y it just keeps getting higher and higher and higher. So those are the situations where we're going to have infinity involved in our domain and range, but I'm going to just kind of zoom in here. So going back here, so this is forming an x, or x, sorry, a v if we were to graph it. So that's what the graph looks like. It forms a v. So our domain is all real numbers again, because we have arrows on the left side of the graph and the right side of the graph. So that's always that's negative infinity to positive infinity. And most of the time, that's what the domain is. Range here, so we have a lowest point that we need to figure out what that y value is, and then it goes up forever. So it's going to go up towards infinity, and then we have our parenthesis. So we need to go back to Desmos to figure out what that lowest y value is. So I'm going to click on the graph, and then go over to where the lowest point is, and it gives me the ordered pair. It says it's -3, 0. So the range is the y value, so that's 0. We need the second value here for range. Domain is the x. So 0 is going to be our lowest y value. So that makes our range start at 0, and then it goes up forever, which we indicate by using infinity. Now, last one that I have here, is it always 0? So that is a good question. Is this always 0? And the answer is no. I can, and this gets into function transformations. So when you learn about function transformations, you'll learn a little bit more about this. I can move it around by adding or subtracting numbers. So if I had 5, my graph goes up, and now it's at 5 as the lowest value. If I subtracted 10, so we can't see it, I got to zoom out. But then we've got the graph, and now the lowest value is at -10. So it moves around depending on where the graph is located. But the domain is always going to be -infinity to infinity. So you always know the domain. You know the range will have a lowest point, but that's why you want to graph it so you can figure out what that point is. Or if you really understand function transformations, you can figure it out from the equation. Basically, whatever number is added or subtracted after the absolute value is going to be your lowest or highest point based off of what the equation is. So if you recognize the equation and you understand what the numbers do to the equation, then you can figure these out without ever graphing them. So that's why we have, I'm pretty sure it's in this week's material, there's like a function, it's called parent functions. It's a download, it's a Word document that you can download, or it's a PDF, but it has all of these rules in there so that you can use it for reference. But it saves you a lot of time if you recognize them, because then you don't have to go into the graphing. You can just look at the equation and you know immediately what is it going to look like. Are there other questions? Okay. So last one here, we've got a square root symbol. And so that's going to be a specific type of graph. It's going to look a certain way. And so we're going to have a domain and a range. And we're going to take a look at the graph to see what it looks like. So I'm going back to Desmos. So I've got y equals, now to enter in the square root symbol, you can use this button right here. And then everything you type is under the square root. And if you want to get outside of the square root, then you have to hit to the right. And it works the same way in Alex. You have the same sort of buttons. Another thing that I use is actually type the word square root. I don't type all of the word. SQRT is a shortcut for square root. So I usually use the keyboard, and I don't even use the buttons. I type all of my math because the shortcuts are the same. That should work in Alex as well. SQRT for a square root should also work. So I notice, whoops, I don't have my 2 out to the left of the square root. Now this is not a to the root. This is just a 2 times the square root. So I'm going to use my arrow key to go back to the left and hit the 2. And then I hit the arrow until I'm back inside the square root. And then I have x minus 4. So this is what a square root graph looks like. It has a stopping point on the left, and then it goes on forever to the right. So I can keep zooming out, zoom out. I can keep moving over to the x. The x goes on forever, and the y just keeps getting bigger and bigger and bigger. So the y also goes on forever. I'll have to go back. So it goes on forever in one direction, not both. So it's sort of like the quadratic in the absolute value, but it's instead of the y that's having an ending point, it's the x that has an ending point. So I'm going to zoom in here. And you can see that if I click on it, it starts at an x value of 4, and then it goes on forever. So 4 is the leftmost x point, so that's part of the domain. So the domain will be 4 to infinity. And then that also gives us the lowest point. The y value here is 0. So the range goes from 0 to infinity because it goes up from there. So that 4, that actually comes from inside here. So that can give you an idea based off of what's inside here where the graph starts. So it's starting at 4, 0. So that's going to be where it starts for the domain and the range. So if I attempt to sketch my graph here, it looks something like that. That's really bad because it really does go on forever, kind of going up if you zoom out enough. But that's what it looks like, and then it has like an ending point there. So our domain, the lowest value is at 4. That's what we saw on the graph, and then it goes on forever towards positive numbers. So that goes to positive infinity. The range, the lowest y value, it started at 0 and then it went up, so it goes up towards infinity. So your domain and range in this case both have a left end point, or if you're thinking of the range, if you're going up and down, it has a bottom point, but then it never stops in the other direction. So you have like a combination for the domain and range. And for all square roots, the domain and range are going to look like that. The numbers will change based off of the equation, but the form will look the same. So these numbers may change, but it's going to look the same way pretty much every time because that's just what the square root shape does. Are there any questions? We're going to be doing a lot of graphing going forward, so I would bookmark this website because it is really nice. All I have to do is push the mouse button and then I can click and drag. You can graph more than one thing. You can graph a table of values by putting in x and y values. If I wanted to, I can even do pictures, which is kind of cool. This wrench button is where you get to settings, so you can change your window. You can change what it counts by. You can add labels. If you want to save the picture, you can click the share graph part, and then it gives you an HTML link, or you can download a picture of it if you want. There's embed code if you're putting it in a website, but this is going to be really handy as we move forward because there's going to be a lot of graphing going on. You can sign up for an account and then you can save it for later. So like I have tons. So like You know, I've just got a whole bunch of different things here from different classes. If you took 104, then you've used this a little bit. But, and there's even examples about graphing, parabolas, like there's a whole bunch of stuff that it comes with, statistics. But I recommend bookmarking this. I think I shared at the very beginning, Desmos is great. It's also got like a actual calculator part. Yeah, Corey says it's a great web page, easy to use, and great for finding points on graph. That's very true. So if I clicked on here, if I click and hold, I can drag and it will tell me any value on this point. So I can find any ordered pair that's on the line, which is really cool. I actually met the guy who is in charge of Desmos. Like he wrote the code and everything, like came up with the website. I actually met him and listened to him talk. So that's really cool. I feel special because I'm like, oh my goodness, I know the web developer. Like I know the guy who invented this web page. So yeah, so that's all I had planned for domain and range. Hopefully this gives you a good understanding of it. You can think of it input or output, independent variable, dependent variable. If you want to think about it in science terms, usually you have to think about, well, what are the independent variables? You know, what values make sense? It's domain and range is usually thought of in terms of that when you have like a real world problem. So if you were graphing something over time, like if I was graphing distance over time, negative numbers would not make sense as an input because you can't have negative time. Just like negative outputs won't make sense because you can't have negative distance. So your domain and range for an equation might be different than the same equation in a word problem because you have to also consider what makes sense in context. So for word problems, sometimes even if theoretically you can plug in any number you want into the equation, some numbers don't make sense to plug in. So that's why we learn about domain and range and understand what it means. It's like, what makes sense in this application? You know, and it's good when you're plugging in numbers and then you get an answer. Does my answer make sense? It's the same sort of idea. It's like, does this make sense? If it doesn't, maybe I shouldn't plug that number in. You know, I should think about, did that number I put in make sense to plug in? So hopefully this cleared things up for you. The rest of the week is heavy on functions. So again, use this website. It'll make things easier for you. You can mess around with it. It might give you a better understanding of what's going on. You can kind of make up your own equations and change numbers and see what happens with it. And that will help you really understand what we're talking about with functions, which is like an input-output relationship. And you can use function notation in Desmos instead of y. You can use the f of x notation and it does it just fine. So I recommend playing around with it, see what it can do. It might, you know, help illuminate things for you. So, all right.